Bienvenidos, Ushamdi, and welcome, CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials version 6 course from the Cisco Networking Academy, or the Networking 2 course at AACC, and this afternoon's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 6.2.2.4, where we're now going to take a look at configuring trunk links between the switches. So let's go ahead and dive in and take a look at our topology. And if you did activity 6.2.1.7, this should look extremely familiar to you because we have the exact same topology, and it looks like we may even have the same IP addressing and VLAN configuration. And this is really where 6.2.1.7 left off, was asking the question, what is wrong with this configuration? And we realized that it was because we didn't have trunk links between the switches. And so as a brief review, let's remember that by default, these ports that interconnect the switches are set to dynamic, and I'll just put DYN, dynamic auto. And that's the dynamic trunking protocol default mode for these ports. And so what happens is, on each side of this connection, this switch says, you know, I'd really like to be a trunk, but only if you want to be a trunk, switch 1. And switch 1 says, well, I really want to be a trunk, but only if you want to be a trunk, switch 2. And both switches are saying, but you have to tell me first. And so, you know, switch 1 tells switch 2, if you're not going to initiate, then I'm not initiating. And so we have sort of this standoff here where neither switch initiates the negotiation to be a trunk link. And so if they're both dynamic auto, then neither side initiates that trunk link, and we don't end up with a trunk link. So it tries to negotiate 802.1q, 802.1q, and when that doesn't work, it falls back to a static access. And that's why we end up, and I apologize here, the pen is not doing what it's supposed to do. And that's why we end up with access ports. And so if it's an access port, and these switches have the default configuration, they're going to be access ports in VLAN 1. However, we're dealing with VLAN 10 and VLAN 20 and VLAN 30. Therefore, the only traffic going across this link right here and this link right here is going to be VLAN 1, because that is the switch port access, is VLAN 1 by default as an access port. And that's what these ports have ended up negotiating to, or falling back to, because they couldn't successfully negotiate their trunking status. So we've got a problem. All right, let's go ahead and take a look at this here and see where we're at. Trunks are required, and so we're going to verify the VLANs on switch 1. Let's issue the show VLAN brief command, and let's bring switch 1 up into the forefront here. And let's make it a little bit larger so we can see what's going on. All right, so here's switch 1. Let's get onto the CLI, where we're going to start out in user exec mode, as evidenced by the greater than sign. I'm going to issue the enable command, and it's going to move us into privilege exec, and I'm going to say show VLAN brief. And as you can see, it looks like we do have all of the VLANs created, whereas in the previous activity we had to create the VLANs. Now, let's see here. There should be VLANs, 10 VLANs in total, and that looks about right. 1, 2, 3, 4, 5. It looks like 88 is new in this scenario. And the 24 access ports are there. Everything is assigned to VLAN 1, and that's correct because that's the default, right? So all ports on the switch are assigned to VLAN 1. So on switch 2 and switch 3, let's take a look as well. So here's switch 2, and let's enlarge switch 2 a little bit. And we'll jump onto the CLI, and we'll go from user exec to privilege exec, and we'll say show VLAN brief. And we can see here that we have the 10 VLANs, 1, 10, 20, 30, 88, and 99, and then 1002, 3, 4, and 5, which again, 1002, 3, 4, and 5, these are here for legacy reasons. You will not end up using those VLANs. And let's check switch number 3 and see what we have on switch number 3 here and make sure that everyone has all of the VLANs configured. So we go from user exec to privilege exec and we say show VLAN brief, and everything looks good to go. Now, it says verify loss of connectivity between PCs on the same network. So remember, the reason that the PCs don't have connectivity anymore is that they're all in different VLANs at this point. Whereas the previous activity, they weren't. And then we put them into VLANs and we lost that connectivity. So switch or PC1 in switch 2, this is VLAN 10, is going to try to ping PC4 over on switch 3 in VLAN 10. And so let's ping 172.17.10.24. And we're going to notice that it doesn't work. And the reason that it doesn't work is because the switch has no way of getting the frame, right, the layer 2 frame that shows up here on the switch. This switch has no way to, it doesn't see the MAC address, right? So the MAC address for this destination is unreachable from a MAC address perspective because switch 2 is only going to know about what it sees locally and then VLAN 1 information from across those access ports right here. Because again, what this is doing with VLAN 1 as access ports, it's just extending the size of the broadcast domain. That's all that it's doing. But it's the broadcast domain only for VLAN 1 that's being extended. For multiple VLANs to traverse a link, it needs to be a trunk link. We can't do it with a single access port because it has a single VLAN assigned to it. Remember, with an access port, we can't have more than one data VLAN. And as I stressed, data VLAN, because if we had a voice VLAN, obviously you'd have 2 VLANs there. So with data VLANs, we can only have a single data VLAN on a single switch port. So in order to have multiple VLANs, we create what are called trunk ports, and that allows by default all VLANs to transit across the trunk link. So let's go ahead and take a look here. We verified the connectivity doesn't work, so we're good there. All right, so now we're going to configure trunk links. So on switch 1, we'll pull switch 1 up. It says configure GIG01 and GIG02 interfaces on switch 1 for trunking. So we'll go from privilege exec into global config with conf t or configure terminal. We're going to go interface range. We're going to save ourselves some time here. I'm going to say gigabit Ethernet 01-02, which means right now I'm modifying both of these ports. So how do we convert this into a trunk port? Well, we say switch port, and actually before I do this briefly here, let's say do show interface gig01 switch port and take a look. What is the operational mode? The administrative mode, which means the mode that it is set to by default in this case, is dynamic auto. But the operational mode, since it never negotiated successfully to become a trunk port, we fall back to static access. And then all that does is it expands the size of the VLAN 1 broadcast domain. And here we see the access mode VLAN is VLAN 1. Now we're going to be changing this. We're changing the administrative mode. And we're simply going to hard code the port to be a trunk port, and my guess is they're going to have us change the, native VLAN looks like it'll be 99, so then we'll see that the default native VLAN, which is VLAN 1, that's going to change as well. So I want to take a look at a before and then an after shot. So here we go. We're in the interface range, and let's say switch port mode trunk, and I could even squeeze that down to be SWMT. Switch port mode trunk. Now, what I don't have to say is switch port trunk in cap, and the command's not even there. So on 3560s, I'll make sure I get this right. On 3560s and older 3550s, you would have to say switch port trunk encapsulation.1Q. And in the reading, you read about the different types of trunk encapsulation. You had Cisco's proprietary and now deprecated legacy ISL for inner switch link. But again, it was Cisco proprietary. And then you had the IEEE standard, which is .1Q or 802.1Q, which is what .1Q is short for. And on 2960s and newer Cisco switches, there's not even an option to set the trunking encapsulation to be ISL. It's only 802.1Q, and that makes sense because nobody is doing ISL between their switches other than legacy Cisco hardware. So 802.1Q is the predominant trunking encapsulation that's used, especially when you're in a multi-vendor environment where maybe you're connecting a Cisco switch to a Juniper switch. All right, so we say switch port mode trunk. I don't have to say switch port trunk encap.1Q. Again, that's the default on 2960s and on newer Cisco hardware. And it says it wants the native VLAN, so switch port trunk native VLAN 99. Now, when I hit enter, this is going to do the same thing that it did in the previous video, 6217. Because as soon as I hit enter here, switches 2 and 3 to whom I'm connected and to whom will now successfully negotiate trunk links, because I've said switch port mode trunk. So in fact, before I enter this command in, let's do it one step at a time. Do show interface gigabit Ethernet 01, whoops, and I want switch port. So let's take a look here and take a look at what's changed. The administrative mode is trunk. In other words, it's on. I've turned trunk on. And the operational mode is now trunking. And take a look at our administrative and operational trunking encapsulation. So administratively, the default is .1Q, and that is what we are operationally using. That's what we've been able to negotiate. And the negotiation of trunking is on. Now, if I want to turn the negotiation off, and this is a Cisco best practice, and a lot of times you'll see Cisco best practices that override the default settings. So you may be wondering, well, why would you say switch port no negotiate to turn off the negotiation of trunking? This is a Cisco best practice, and it overrides the Cisco default. And again, it's to ensure that the dynamic trunking protocol is off, that we have to hard code this. So now when I say do show int gig01 again, you'll see, where did we go here? I think I went right by it. And where did it go? Oh, I'm sorry, there it is. Negotiation of trunking. I totally lost where it was. Negotiation of trunking is now off. So switch port no negotiate turns the negotiation of trunking off. It turns the dynamic trunking protocol off. And again, we've hard coded the port as a trunk, so we don't need it to negotiate. So that's one of the reasons that you turn it off. Now let's go ahead and change the native VLAN from 1 to 99. So switch port trunk native VLAN 99. And we're going to see a spanning tree error. An inconsistency is going to get picked up, and it's going to block the port. And so as soon as I issue that command, we'll give it a second here, we should see, as soon as CDP does its thing, we should see, oh, and it wants us to fast forward. Yeah, right. Okay, so we've got, yeah, there we go. Okay, so we've got our native VLAN mismatch, and it looks like it may have negotiated the trunking status before I entered that VLAN 99, so we're not seeing the inconsistency. But what we are seeing is that there's native VLAN mismatch that's taking place here. So we have to configure the same native VLAN between each of the links. Now, this is something that's important. The native VLAN is a point-to-point concept. In other words, the link from here to here could have a native VLAN of 99. And the link from here to here could have a native VLAN of 88. So again, it's a point-to-point concept. It just has to match between the two endpoints here. And if it doesn't, that's when you get this native VLAN mismatch error. And again, this is a common error that you'll see sometimes when you're configuring things, because you do the configuration here, and before you have a chance to do it here, you see that, oh, we've got a native VLAN mismatch. And again, remember, that is a point-to-point concept. So you don't have to have the same native VLAN on every single trunk port on every single switch, because it's locally significant on that link, right? So keep that in mind. Keep that in mind. Okay, so we've got the native VLAN mismatch error, and I'm just trying to catch up here. You configured VLAN 99. Okay. And it says, although you have a native VLAN mismatch, pings between the PCs on the same VLAN are successful. Why? And this is a great question. Really glad that they add this question in here. So you can see that I can ping, and let me pull up PC2, who will ping PC5. Let's pull this back just a skosh. And we'll say ping 172.17.20.25. And that works like a champ. And then we'll come over here. And I did not want to do that. Let's bring this out of the way a little bit. We'll come to our desktop and we'll say ping 172.17.30.26. So we've got connectivity right now between hosts on the same VLAN, even though we have a native VLAN mismatch. Now, the question as to why are those pings successful? And this goes back to our conversation in the previous video. Remember that trunking is working, and when I pull the switches back up, I'll use the command show interface trunk, and you'll see that the trunking is working. And again, by default, a trunk link allows all VLANs to transit it. So that's why we've got the connectivity. But here's what you may be wondering. But the native VLANs don't match. In this context, in this use case that we have here, where everyone is in a defined VLAN, it will work. Because when the traffic shows up on switch 2, switch 2 knows that PC1 is in VLAN 10. And it will get tagged, it'll get that 802.1q VLAN tag of VLAN 10. Because that's also how the MAC addresses are organized and segregated on the switches, is that switch 1, and we'll look at that in a second here, is that switch 1 will have a VLAN 10, and this is why it's so critical that the VLAN 10 exists on all 3 switches, because it's in that VLAN that the MAC addresses of the PCs and nodes in the VLAN are going to reside. And so it gets tagged with VLAN 10 here. The frame shows up here, and switch 1 says, oh, you've just shown up and you're tagged with VLAN 10. Let me see your source and destination MAC address. And more importantly, it wants the destination MAC address, and it looks into the MAC address table for VLAN 10. It doesn't look in the MAC address table for every MAC address entry on the switch. It looks in the MAC address table for VLAN 10. And again, that is why we have to have VLAN 10 from start to finish, from cradle to grave on the path that this frame is going to travel. So then switch 1 says, oh yeah, I see that the destination MAC address you're trying to get to is in VLAN 10, and I'm learning it on that port right there. That's the port out which I'm going to send you. So then the frame shows up here, and the switch looks at it, and it says, oh, I noticed that you have an 802.1q tag because it was tagged on the egress coming this way. And switch 3 says, let me look into my MAC address table that I have for VLAN 10. And let me see if the destination MAC address you're trying to get to is in that MAC address table. And it says, you know what? It just so happens that it is. And in fact, it resides, that MAC address, destination MAC address resides on that port right there. And that is the port out which I send the frame. Because remember, Before we look, before the switches are going to look, and again, the switches are layer 2 switches, right? These are layer 2 switches. So I'm going to make a statement that says before they look at the IP, and again, they're layer 2 switches, they're never going to look at the IP address. But the point being is that if they were to look at the IP address, right? Let's just do the 7-layer OSI model here. And what do I have? 1, 2, 3, I'm short 4, 5. Okay, I made it. 6, 7. The frame, and this is why we say it's a layer 2 switch, because layer 2 is the physical address, is the MAC address. The PDU at layer 2 is the frame. So the switch is going to look, right, because the bits come in at layer 1, right? So let's say that the frame is coming, from switch 1 to switch 3. And if we're looking at it like in this direction like this, the first thing it's going to see is the layer 1 information. And then after that, it's going to be the layer 2 information, right? Layer 1 is just the bits. But then layer 2, it says, source and destination MAC address. And that's how the packet's getting forwarded. So let's take a look at that. Let's see what that looks like, because this is critical. These are very fundamental, foundational topics that are required for understanding and help you with topics like this to see. And I'm going to do a ping, but I'm going to make sure the MAC address table is populated. And we may get a request timeout here maybe before it ends up working. And this is all I'm doing is I'm running the ping to make sure that we have reachability. And then I'm going to take a look at the MAC address table. And we should not have these timing out. PC1, 172, 1710.24, 172.17.10.24. I should have success here, just like we did before, and it looks like we are not. And I'm wondering if this is a packet tracer bug. Let me read this again, and let's make sure that where we were at here. So pings between PCs on the same VLAN are successful. Maybe it was good for one. Let's check packet tracer, see if it's packet tracer. So can I ping over to PC5, and it appears that this is not cooperating. And maybe I waited. No, it's not that I waited too long. Do show, let's get back into privilege exec here. Let's do some troubleshooting. Show interface trunk. Whoops, show interface trunk. All right, so it did not negotiate the trunk link, even though it initially allowed me to ping across. So it looks like I may have waited too long with an explanation of what was going on there. And so let's do this. Let's finish the trunking config on 2 and 3. Take care of the native VLAN mismatch. And then we'll take a look at how it's being forwarded here. So let's get into global config interface. And let me see what interface is that here. It's gig 01. So interface gigabit Ethernet 01, switch port mode trunk. Switch port trunk native VLAN 99, and there's that PVID spanning tree error, because again, I changed it right away. Spanning tree picked up on, hey, there's a problem here. We're basically blocking the forwarding of traffic on that port. So that is all we need, and we'll go ahead and we'll say switch port no negotiate as well. Then we'll come over to switch 3, and we'll do the same thing. We'll go from user exec to privilege exec. And the global config interface gigabit Ethernet and a 02 interface gigabit Ethernet 02. Switch port mode trunk, switch port trunk native VLAN 99, and the inconsistency has been cleared. So now we're back to a consistent state, and then switch port no negotiate. Now we've got the 80 out of 80, right? But let's take this a step further, because it's critical to understand what is going on here and how this is working, because a lot of learners will become confused and think, oh, well, it's looking at the IP address and the host is looking at the IP address, right? But the switches are not looking at the layer 3 information, because these are layer 2 switches. These are not multi-layer switches. So if I come to the host, and now the ping should work magically, and of course it does. So we've got connectivity, and everything looks fine, right? So now the MAC address table in all three of these switches should be populated. So let's start here on switch 2. So if I say show MAC address table, we take a look and we see that it's broken down by VLAN. So take a look, we've got 3 entries here for VLAN 10. Now before we do that, let me pull up PC4, which is the PC we're pinging, because we want to look at the desktop. I want to come to the command prompt, and I want to say ipconfig-all. And what do you think I'm coming here to see? I'm coming here to see the MAC address of PC4. Because here's what's happening. On switch 2, what are the 3 MAC addresses that we see in VLAN 10? Yeah, we see that's PC1, and this is probably the other switch. And then what do we see here? Lo and behold, Baker Echo 75, we see the MAC address for PC4. And the only reason we see that is because that VLAN is propagating across all 3 of the switches, right? So on this host right here, when I say ping 172.17.10.24, the host goes ahead, and if the host has a network entry for it, it will send that traffic along to the switch, and the switch is interested in the layer 2 information. In fact, if this PC had to ARP because it didn't have an ARP entry on the PC, if it sends an ARP, the switch is going to respond back and say, yeah, hey, I know when you say ping 172.17.10.24, what does ARP say? The address resolution protocol says, hey, I know the IP address. Can somebody give me the layer 2 information? I need the layer 2 information to get this packet going to where it's supposed to go. And that's what the address resolution protocol is all about. And so what happens is the host might have to ARP, right, if it doesn't have an entry for it, and then it will go ahead and send the frame down to the switch. The switch looks at this, and look what the switch says. I'm learning it out port gig01. That's the same port it's going to send it, right? It's going to send it out that port. And so what happens is switch 2 gets the frame and says, yep, send it out gig 1. Switch 1 is going to get the frame and say, yeah, I learned that out gig 2, so I'm sending it this way. And switch 3 is going to get it and say fast Ethernet 011. Just like we had 011 here, right? It's going to be the same thing. And so let's see that. Let's pull up switch 1. And on switch 1, if I were to say, show MAC address table, and it looks like it timed out. The default is 5 minutes, so I may have been talking for a little bit too long there, but there's an easy way to get it back in there. It's to send a ping. And look who just showed up right here in VLAN 10. And it says, hey, I know about it through gig02. So we send it out gig02 to switch 3. Switch 3 gets the frame and says, all right, where's the, do show MAC address table. Where's the destination? The destination MAC address is Alpha Charlie 93. Yep, I know about it. I'm firing it out. Fast Ethernet 011. And then it shows up here at the PC, and the PC takes a look at that. Remember, the layer 1 information, the bits come across the wire. Then it looks at the layer 2 information. And when it looks at the layer 2 frame, it says, I'm not interested in the destination MAC address. I'm not interested in the source MAC address. I'm interested in the destination MAC address. Is it me? And when it looks in that destination MAC address field and it sees its MAC address, then it moves up to the layer 3 and then the layer 4 and so on. Because once it sees that its MAC address is in that destination MAC address field, it says, hey, that's mine. I'm going to pull it off the wire and let's go ahead and process that frame. And that's how forwarding works at layer 2. So again, the IP addresses are great, and that's how we as humans know, oh yeah, 172.17.10.24. However, once we type ping and the IP and hit enter, Everything in this context right here with layer 2 switches, not multi-layer switches, it's all getting done at layer 2. All right, guys, well, that is going to wrap up Packet Tracer Activity 6.2.2.4, where we took a look at configuring trunk links. We talked about the switch port mode trunk command. We talked about the fact that 802.1q is the IEEE industry standard. It is also the default on 2960s and the most recent Cisco switches.